Hi, welcome to this TechnologyCatalogue.com webinar. My name is Vincent van Beuzenkom, Managing Partner at TechnologyCatalogue.com. Our focus for today will be on two technologies around corrosion under insulation, still a hot topic in the energy industry. For that matter, I'll be joined today by two of the suppliers from the Technology Catalogue. The first presenter today will be Riccardo Scottini from TUV Rheinland Sonovation, talking about the SONOPEC technology. Thereafter, Chiraz Ennaceur will actually be presenting the CorrosionRADAR CUI monitoring technology. Both of these technologies can be found in the maintenance and integrity section of the Technology Catalogue. The SONOPEC technology can be found in the corrosion control submodule, and the CorrosionRADAR technology can be found under predictive maintenance technologies. Before I hand over to Riccardo for the first presentation, I would like to let you know that if you have any questions for the presenters, you can type them using the chat functionality on the right, and they will be picked up by us during the Q&A session following the presentation. With that said, I would like to hand over to Riccardo for the first presentation.
Now, thanks for joining the presentation and to you, Vincent, to give us this opportunity. I'm Riccardo Scottini, and I'm the Business Development Manager for SONOPEC and the PEC business for TUV Rheinland Sonovation. SONOPEC is a corrosion detection and monitoring tool that is an efficient, I would say, cost-effective solution. Now, what SONOPEC is effective in detecting, therefore, corrosion in piping, vessels, corrosion under insulation, but also under fireproofing, wrapping repairs, and is a unique also solution to get result through galvanized sheetings, which has properties similar to the base material of the pipes or vessels. And it also has a kind of, I would say, Faraday cage to the magnetic field we use to detect the corrosion. The tool has also a very interesting algorithm called the defect mode or defect wall thickness algorithm that may detect smaller indications within the probe footprint. We do have an advanced data presentation, 3D models and data presentation are shown on the right side of the slide. We can even present a measurement on elbow with a fixed step or fixed grid, or with the same number of points in the introdocs and at extradocs. The team has, at least all the guys have more than 20 years experience with pulse eddy current, and therefore we developed during the years lots of experience but also know-how. Measurement may be encoded. The equipment is portable, is battery operated, and is suitable for RV study, maintenance plans, and asset integrity optimization. So, how does PEC or pulse eddy current or SONOPEC works? We create, first of all, a steady magnetic field through the transmitter coil of the PEC or SONOPEC probe. The duration of this field will depend on the thickness of the object under examination. Once the magnetization in the base material is uniform, we will suddenly switch off the sending coils, and at this time there will be a transient in the base material. So we will see eddy current starting to be generated from this magnetization change and variation, and they will start to migrate through the wall. Once they reach the opposite side of the plate or the pipe opposite to the probe, this signal will have no material to diffuse and will disappear. And is what we see in the graph. We see a bending point, so we see a linear decay, and then after a bending point, and this time is related to the average wall thickness of the object, the magnetic permeability, and also its electric conductivity. If an object will get thicker, the bending point will move to a longer time. If it will get thinner, we'll move to thinner time. And corrosion may be seen as wall thinning, so this is what we may detect. Application: corrosion under insulation, corrosion under fireproofing, storage tanks and annular plates, which is an application very common in the Netherlands, where most storage tanks are on a sandbed, so easy to access to the probe. But in other countries, it may be the shell is just over a concrete ring, so only a limited part will be accessible. But this is also the area where we have the most corrosion in storage tanks from outside. In-service corrosion monitoring, where we can also fix, for example, on column probes in areas that are difficult to be accessed. And then we have a junction box where we can connect, for example, on the platform, the equipment and perform the measurements. The technology is also efficient in high temperature surfaces and on heavy corroded equipment, and also on offshore riser and caisson, where we also inspect wells. So the equipment may be applied from wall thicknesses from 2 mm up to 70 mm. The maximum insulation thickness is approx 200 mm. The object temperature is up to 500 C, and this limitation is mainly due to the electromagnetic properties or carbon steel or low alloy carbon steel. Because if we go over 500, 550 degrees, the electromagnetic properties start to get unstable, and this will create a fluctuation in the measurements. Piping diameter larger than 2 inches. Accuracy 95%. This means that if I take a reference point, so a location where I perform a measurement and then will compare with all other locations where we take the measurements, the deviation will be in the 5% to this place. Repeatability 98%. It means that if I perform a measurement today and another colleague will reperform the same later, the deviation will be in the plus minus 2%. The equipment may operate in a large environmental temperature range from -20 degrees Celsius up to 50 degrees Celsius, and also in a humid environment, and is water splash proof with IP65. And we can do lots of application with the probe, so the same probe can be applied in different ways, and this can be cost effective and have lots of benefits. Further, the equipment is robust, there are no moving parts, and is battery operated. The software is user-friendly. It has lots of features that helps the operator or the user to find solution and to make a right interpretation of the results. He has advanced data analysis and evaluation algorithm. For example, the footprint that find a thinner wall within the defect mode that will find thinner area within the footprint area. It has may have 2 independent probe channels, an XY encoder, which will allow also continuous measurement or encoded measurement. Data may be presented in different ways, like graphs, 3D projection of result on objects, and also present information that will help the operator or the user to find the right solution, the right results, and the right interpretation of the whole inspection. And I have to say, the equipment has also been designed to be expanded with multiplexer, with multi-channels modules, and the main application are, in this case, are focused on subsea application, non-piggable subsea pipelines, and the probe will be then deployed with ROVs or crawlers. To reach a conclusion, the technology is suited for RB study, so risk-based inspection, is a non-intrusive inspection method as we do not need to remove any insulation to perform a measurement. Is a fast data collection. We are in the order of some fraction of seconds up to some seconds. We do have a real-time interpretation and we directly see our results. No need to remove insulation, no need to clean, no need to prepare the surface. Technology may be deployed with row passes, cutting down the cost of scaffoldings. In service monitoring, deliver really accurate corrosion rates results. The technology is also effective above and underwater, as water is not interfering with magnetic fields. And it is a real unit solution for non-piggable subsea pipeline. And we do have a dedicated PEC innovation team with more than 20 years experience and know-how. And this helps us to create tailor-made solution. So this was my presentation, and he has my contact information. Is there any question?
Thanks, Riccardo. I think there have been some questions already coming in online, so maybe you can start with those.
So I see, okay, I just take Anthony Morgan ask, will this technology work through an ice ball? Yes, for sure. As water, ice is not interfering the magnetic field. We operate the technology on some installation that has even minus 100 degrees Celsius. So cryogenic application is one of the scope. But I have to say that 90% is CUI or CUF in the petrochemical. And then I see Martin ask, how many measurements can you take on an average a day? Yeah, it depends. It depends on the situation. Just to give an idea, to take a measurement on a 10 millimeter wall, it's just maybe it takes something like half seconds. It means that in 1 second or 2 seconds, I already have some measurements. And if all these points are next to each other, I can maybe do 3, 4, 5,000 measurements in a day. But if I have, for example, a vessel with a heavy wall of 60 millimeter wall, then it will take a measurement can take up to 10 seconds. So I'm limited to maybe 2-3 measurements per minute, because I need to place the probe and then place it to the next location. And if my object require to climb up and down to move in the installation, there are different location I have to inspect. Then it will take the production will go down, and it will be very fast if all the measurements are next to each other. Is there any other question?
Maybe a question from this side,
yes.
Riccardo. Can you perhaps say a little bit around just the comparison if you would take a traditional case for delagging equipment and use traditional techniques? Do you have perhaps examples there on what the impact would be for the operator?
Yeah, we had the experience in the past with inspection on columns, and the client said, if he was happy for the job, because he said, if I have to strip the column, remove the insulation, I will have also waste material. I have to reorder material and reinstall it. He said that the costs were in the order of 1 million euros. So this was already what he spared. Of course, the inspection costs money, but what's happened is that he could verify only, or at least remove insulation for verification, only on the area where corrosion was found. And there was no need to strip the whole area. So this can be a huge advantage of the technology. Yeah,
I can see that. Okay, thanks for that.
Yes.
I see no more questions coming in from online. But still, of course, if you have questions for Riccardo, you can always ask them later via the SONOPEC page in the technology catalog. Also, if you happen to look at this webinar as a recording, you can use the catalog page to ask any questions for Riccardo. I would like to now hand over to Chiraz for the second presentation on corrosion radar. I know that Chiraz had some IT issues earlier, so I hope you can hear us now and we can hear you, Chiraz.
Yeah, so far so good.
Yeah. All right, that's good.
Okay, thank you very much. Okay, so my name is Chiraz Ennaceur. I'm the CEO and co-founder of CorrosionRADAR, a company based in Cambridge in the UK. So today I'll be talking about the biggest failure mechanism in the world, which is corrosion. Corrosion affects many sectors and it comes at different shapes and forms. I'm not going to be talking about all the different types of corrosion. I will talk about hidden corrosion and more specifically corrosion under insulation. Corrosion under insulation has been a big headache for many industry for decades, and it's a problem because it happened under the insulation. It cannot be seen, it cannot be monitored, and cannot be detected. So when you are managing assets with insulation, really, if we summarize the two questions that you need to answer would be where the COI can happen and when the COI can happen. And if we see the current practice, which is heavily dependent on periodic manual inspection and probably more on visual inspection, and it depends on a lot of human judgment, either that is using RBI or statistical data or historical data. If we use these two approaches, we are not really answering the where and when, because the COI is very unpredictable. Sometimes you have a weakness in the cladding at a certain point, the water will seep in and will settle down in a different point, and that will cause COI. So it's very unpredictable, and if we have to decide first where to inspect, then all the unpredictability question remains the same. So because of the visual inspection, because of the labor intensive current practice, for the cost of COI for oil and gas sector alone is more than 3.5 billion a year. And big part of that goes to the fact that you have to build the scaffolding and to remove the insulation. So ideal practice is really to have a continuous monitoring, a way and a tool to automate and risk profile your assets to really narrow down the area of concern and know where and when to inspect. So moving the whole COI management from reactive to predictive. So having that in mind, at CorrosionRADAR, we have developed a new technology. It's a patented technology, and it's a solution where we develop like a nervous system fully embedded with the assets to pinpoint the area of concern from a COI point of view. The solution has three main elements, what we call detect, connect, and predict. Detect is our hardware, and we have sensors, two types of sensors, corrosion sensor and moisture sensor. Both, they come at 100 meters each. They are permanently installed between the assets and the insulation. And they do, for the corrosion sensor, detect and locate where the COI is. And for the moisture sensor, detects and locates the presence of water along the 100 meter where the sensor is installed. It's very modular and it has ATEX electronics. The electronics are there to send electromagnetic waves within the sensors, and these waves come up with the information about the COI or about the water presence. We want to make this autonomous, so we do make our system compatible for wireless communication protocols. And for now, we have commercially available with the cellular connectivity with LoRa and with the wireless HART. And for the predict side, we use our unique data to have a more accurate prediction about COI, and that provides a very valuable insight to the asset manager from a COI management point of view. I'll show you a video. A video is recorded with my voice, so to give you an idea about how this CorrosionRADAR technology could be used on a plant. Just to give you information and a view about how, in practical terms, corrosion radar system could be used, we have produced this digital twin simulation. And as you can see here, there's a plant with assets with different colors. These different colors shows the different severity of CUI in each location, each asset. I'll go through different examples here. We have a vertical pipe. We have where we installed a vertical sensor installed permanently between the insulation and the pipe. The sensor giving real-time data about the health of that pipe in terms of CUI. The data could be visualized in different ways. And as you can see here, there's an indication that has been detected by our system, localized, showing that at a particular location there is a high level of CUI that has been detected, so the asset manager needs to take the right measures. Our system is not only for pipelines, it could be also used for different other assets. Here we put an example of a tank. The system here is designed in a ring configuration, and again the system giving information about CUI level in that asset. And in this particular example, we have not detected any CUI, so the manager does not have a need to remove the insulation and unless a CUI level has been detected. Our system is very modular, very flexible, can deal with complex geometries. Example here is a complex pipework with flanges and with bends. The system has been developed in a coiled way, and in this example you could see that a medium level of CUI has been detected and localized around the pipe bend. The system can be used for large assets. In this example, we have a vessel where we have designed the sensor in a mesh configuration, and as you could see, this can help to really localize with a better accuracy the areas that are concerned with the CUI. And in this example, you have two areas detected, one with a high level of CUI and the second. Okay, you still hear me? Okay, so I hope that gave you an idea about how this corrosion radar system could be used to monitor and pinpoint and narrow down the areas of concern in your plants. And now I'm going to give a couple of case study where we have done deployments on different type of assets. Case study A, it's on a tower where so this is an old tower, and the client has seen already some CUI on this tower before, and during a turnaround they decided, before putting the new insulation, they have decided to install CorrosionRADAR CUI monitoring system. And the idea behind this is to detect the CUI at an early stage and also narrow down the point of concern, so you do not have to erect the scaffolding again when the next cycle of maintenance comes. So for this application, we have installed, as you could see here, two sensors, one at the top and one at the bottom, and we have installed an ATEX electronics that is suited for that environment. The case study B, we have installed both corrosion sensor and moisture sensor, and this is installed in Asia, in a country where it rains a lot, so the possibility of having a CUI also increase. I will show you the data from this deployment after 6 months. You could see at the top is the corrosion monitoring data, and at the bottom is moisture data. So we could see here, after 6 months, we started seeing some water settling in at the bottom corner of the pipe, as you could see at the bottom of the slide. And from a corrosion point of view, there was no corrosion detected at that point. Then the monitoring continues, and after 9 months, if you see at the bottom, which is the moisture data, indicates that actually water has seeped in everywhere in this pipe. We could see water at the top of the pipe where we have a flange, and you could see also water settling in at low points. But also what is interesting is that water at certain location has led to the presence of CUI. As you could see at the top graph, you could see CUI has started at the top of the pipe, but also at one of the corners, CUI level has been detected. So the point here is that when this pipe has been refurbished by the client, the next cycle of inspection was scheduled for the next 5 years. But here what we are showing to the client that actually water is seeping in, the installation is not done properly, and actually due to that, CUI process have already started at certain location. So this is an indication to the client to make some action in order to avoid major repair or catastrophic failure within this 5 years cycle period. So to summarize the benefit of CorrosionRADAR as a CUI monitoring and prediction solution, we have a cost and risk benefits. And the main reason for that is with CorrosionRADAR monitoring system, we detect corrosion at an early stage, which is the cost and the risk associated in dealing with it is much lower than finding corrosion at an advanced stage using the current process, or not finding corrosion at all, and then can lead in a too much catastrophic failure. In addition to the early detection, also the data from CorrosionRADAR, either the CUI or the moisture data, can be used with RBI, and that leads to data-driven RBI. A data-driven RBI that helps to optimize the maintenance, have a less human intervention, reduce the risk to the assets, reduce unscheduled shutdown, which is a big nightmare for assets manager, leak prevention, and reduce the maintenance cost. So this help in getting much more preventive way of dealing with the CUI, and also why not CUI prevention by using the moisture sensor. So a summary here, what I would like to say is CUI has been a problem for many decades to many industries, and something needs to change on the way how we manage CUI. Prevention only, because what you hear people talking about prevention, I'm going to make the right coating, the perfect cladding, the perfect insulation. What I would say, prevention only is not the one answer, one solution. CUI monitoring is also part of the solution. So wherever you apply a new process, new coating, you always need to monitor if that is doing what it's supposed to do, because if everything was perfect from a cladding, from insulation, from a coating, we would not be talking about CUI until nowadays. So CUI monitoring is a big part of the solution. And at CorrosionRADAR, we are offering one and unique offering of a distributed sensor network that helps in real-time monitoring of CUI and the presence of water, which also leads to CUI. And using these data helps also in moving from a reactive to predictive CUI management. So thank you very much for your attention, and I am happy to answer any of your questions.
Thanks for that, Chiraz. And I think we already have some questions from the viewers online. So perhaps you can pick up some of the questions that are already there.
Yeah. So Anthony asking if this device is intrinsically safe. So we have an ATEX enclosure that we are using at the moment. And as a next generation of our product, we are making a more customized system that could be used for all type of environments. And in my case A, I showed one of the types of the enclosure that we use. I will also answer Martin, how would this work around nozzles, which is most sensitive due CUI? Actually, this is a perfect solution for nozzles because the sensor is very flexible. It's like a cable, and we can wrap it around different complex geometries. And nozzles or pipe bands or manholes are also an application where we add value there.
All right. Chiraz, maybe also a question for you from my side is that you mentioned, of course, the fact that which makes it costly around the inspection scope is the high unpredictability around corrosion under insulation. For me, that still is also partially an issue with looking at your system, because I expect you will not have 100% coverage. Can you explain a little bit on how you go about in selecting what areas you would deploy your sensors?
Yeah, so I mean, you will never ever have 100% coverage for all the assets. What we do, we give much more coverage than what is existing right now, and also it's a continuous monitoring. So always compared to you know, the data that you had day one. In terms of coverage, we really work with the client very closely on different assets. So we customize the deployments for specific assets, and we do advise on the type of deployments that we believe will give the more optimized type of coverage. We have different types of deployments. It could be a straight line. If we have a small pipe, it could be coiled around the pipe. If we have a vessel or a big asset, big area to coverage, we can design the sensor in a mesh configuration. So there are different ways of deploying the sensors to give the more optimized way of optimized coverage required by the client.
Okay, thanks for that. Let's see if there are any other questions remaining online. I don't think any new questions came in. So actually, we're also right on time. So that's a nice way to stop the Q&A. I would like to thank both presenters for today. And as I mentioned earlier, if you have any further questions, either use the contact forms on both the sites in the technology catalog, or contact us directly on the email address that you see here on the screen, in case you have any further questions or you'll be interested to learn more about these webinars. That also is the case if you're watching the recording, then you can always reach out to us if you want to know more about these two technologies. For now, I'd like to thank you for joining and hope to see you again online next time. Bye-bye.
Thank you very much.
Bye-bye.
Bye-bye.